Quiz is on chapter 7. It's all about logs. It's about 15-ish questions, and it's going to be no calculator. So I'm going to go through the review. If you want to see anyone specific, just stop me, but I'm going to do a little bit of each type of question, and then I'll post all the answers by lunch today, probably. All right, let's look at A. So we want to simplify. We want our base of our log and what we're taking the log of to have the same base. So how can I make 25 have a base of 5? It'd become 5 squared. So we have log base 5 of 5 squared. What do I do with the exponents now? Multiply them. So log base 5 of 5 to the 4th power. Log base 5 of 5 cancels, so we're just left with 4. So if you see something that could potentially have the same base, simplify it. Let's look at, what about for C? What would I do here? Yeah, we could do it that way. So I could say log base 4 of 1 equals x, and then we could rewrite it in exponential form. So 4 to the power of x equals 1. So x would equal 0. Perfect. Anytime you take the log of 1, it's going to be 0. So if we wanted to do this using the change of base, we could have said log of 1 over log of 4. We know that log of 1 is going to be 0 over, it doesn't matter what log of 4 is, because when we divide 0 by anything, we'd get 0. So you can think about it either way. Let's look at D. What's our base when our base of the log when it's not written? 10. So log base 10 of 10 would be what? 1, perfect. We'd be left with whatever our exponent is here. If there is no exponent, it's implied that it's a 1. So this would just be 1. What happens to the ln of E? It's 1. So same thing. ln is log base E. ln is just a different way of writing it. So if you think about it this way, log base E of E would cancel. We're just left with 1. Or ln of E cancels. We're left with whatever the exponent is, which is 1. Let's do G also. So here we can move the 9 to the front. So we have 9 times 3. So this would be 27 out front. What happens to ln of E? It'd just be 1. It cancels there. Minus ln of E is going to cancel here, so we're just left with 2. So 27 minus 2 is 25. You'll have a question like the next one where you have to change the base. Again, the quiz is no calculator, so you would just leave it as a fraction, whatever you would put. We're just changing the base using the formula. So you write your answer the step before you'd put it in the calculator. So here we have log of 10 over log of 2. And then for B, we'd have log of 7 over what? Log of 10, awesome, because our base here would be implied that it's a 10. What is log of 10? 1, awesome, because our implied base here would be 10. So log base 10 of 10 would be 1 over log of 2. And this one would be log of 7 over 1. So that's as simplified as we can go there. Any questions there? You want to simplify it all the way. This one we would want to write it as log of 7. But just always keep your eye out to see if it could be simplified anymore. If it was 2 logs that you can't simplify anymore, you would just want to leave it as a fraction. For the next one, we want to find the domain and the x-intercept of our log graph here. So it's important to know that our log graph has this shape unless we have a transformation happening to it. So for our domain, in our basic, if this was log base 2 of x with no transformations happening, our domain would be from 0 to infinity. But our domain changes if we have something happen to it, if we have a transformation occurring. So we'd set whatever's in our parentheses equal to 0 to find what the domain is. So here our domain would be x plus 3 equals 0. So x equals negative 3. Now we have to write our domain in interval notation. Since I don't have a reflection happening here, my graph is still going to infinity. So it's going to start at negative 3 and go to infinity. And then how can we find our x-intercept? What would we do to find the x-intercept? Plug in 0 where? Into the y. So I'm going to plug in 0 into my f of x here, because that's our y. So we have 0 equals log base 2 of x plus 3. Now here we just need to solve for x to find our x-intercept. What would we do to solve for x? How can we get it out of log form? We can put it into exponential form. So I would start with my base of the log, which is 2, to the power of 0 equals x plus 3. Or if you wanted to think about it, whatever our base is, we'd make the big base 2. So 2 to the power of 0 equals 2 to the power of log base 2 would cancel, and we're just left with x plus 3. So you could either put it in exponential form or make the big base 2 on both sides. It'll cancel out. You'll end up with the same. So what's 2 to the power of 0? 1 equals x plus 3. Subtract 3. X is equal to negative 2, so our x-intercept would be at negative 2, 0. Let's do B also. So B is a little bit different because we have a negative being multiplied to the x. A negative multiplying directly to the x is a reflection on which axis? The y-axis. So instead of my graph looking like this, it's going to flip on the y-axis and look like this. Not this one. So keep that in mind when we find our domain, because now our domain is going to be from negative infinity to wherever our parentheses equals 0. So we still find it the same way, but instead of going to positive infinity, it goes to negative infinity. So here I would say 0 is equal to 2 minus 3x. When we solve for x, I can add 3x to the other side and divide by 3. So x is equal to 2/3. So what would my domain be? Awesome, negative infinity to 2/3. Perfect. And then to find our x-intercept, we do the same thing we did in the last one, make the y 0. So 0 equals 4 log base 3 of 2 minus 3x. Bella?
What is it? A reflection on the x-axis?
If you multiply the x by, we were to multiply by a negative on the outside, that would be on the x-axis.
Oh.
But the x-axis wouldn't change our domain, because if we had our graph look like this, our basic log graph, when we flipped it, bless you, on the x-axis, it would still be like this, so it still goes to infinity. So a negative on the outside is a reflection on the x-axis. Inside, directly to the x, is the y-axis. So the y-axis is what's going to change our domain. So for our x-intercept, when we set it equal to 0, what would we do next to solve for x? We want to divide by 4 on both sides. Let's get the log all by itself. So we get 0 is equal to log base 3 of 2 minus 3x. What's next? Put it in exponential form. We're going to say 3 to the power of 0 is equal to, if we raise both sides with the big base 3, this cancels. So 2 minus 3x. What's 3 to the power of 0? 1 is equal to 2 minus 3x. And then we just solve for x. I'm going to subtract 2. So negative 1 equals negative 3x. X is equal to 1/3. So our x-intercept would be 1/3, comma, 0. All right, let's look at the next page. We're going to expand and simplify. So let's do A. So when I expand my log, if I'm multiplying, I'm going to expand it with addition. So every time I break it apart, each term is going to get its own log. So log base 2 of 4 plus log base 2 of x cubed. Any exponent would need to go to the front of that log, turn into a coefficient. So we're going to move this in front, make it 3 log base 2 of x. Now let's think about, can we simplify any more? Log base 2 of 4, can that be simplified? Yeah, how can we get them to have the same base? Awesome. This would turn into log base 2 of 2 to the second power. 2 to the second power is 4. So log base 2 of 2 would cancel. We're just left with the exponent 2 plus 3 log base 2 of x. This would be our answer. So this would be as simplified as we can go. Always, 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 if you just have numbers there, just check, make sure you can get the bases to be the same. If you can, you need to simplify it all the way. So if we only had, like if this was log base 2 of 2, it doesn't disappear, it would turn into 1 plus whatever you have after. So with B, we have division and multiplication going on here, but we have to be careful. Anything on the top gets a plus sign. Anything that we're dividing on the bottom is going to get a minus sign. So here we have log base 3 of x squared. Then because 3 and y to the 4th power on the bottom, they're both going to get a minus. So minus log base 3 of 3 minus log base 3 of y to the 4th power. Now I can simplify this a little bit more. I'm going to move my exponents to be coefficients. Is there anything else I could do to simplify? What? Log base 3 of 3 would turn into what? 1. Perfect. So this would be 2 log base 3 of x minus 1 minus log base 3, 4 log base 3 of y. So looking at F, I'm going to break this up with subtraction. So I have log of 3 minus log of 100. Can we simplify this anymore? Which one? Log of 100. What's the base on my log here? 10. So how can I make 100 have a base of 10? Awesome. Log base 10 of 10 squared. So 100 just turns into 10 squared. Log base 10 of 10 is going to cancel. We're left with 2. Bless you. So I have log of 3 minus 2. Any questions here? And let's look at G. So here again we have division, so that means that we're going to subtract. We have the ln of 2 minus the ln of e to the 7th power. Can we simplify this anymore? Ln of e is going to cancel, so we're left with ln of 2 minus what? 7. Awesome. Let's do H. So again, we're subtracting subtracting because we have division. So log base 6 of 1 minus log base 6 of z squared. What is log base 6 of 1? 0. Awesome. If we take the log of 1, we would get 0. So this cancels out to be 0. So this one actually just goes away. And then we can move our 2 in front here. So negative 2 log base 6 of z. We'll do d also. Let's look at d. So here, everything has that cubed root on it, so everything would be raised to the 1/3 power. So we could move that in front of our log now, and then just make sure it gets distributed to everything at the end. So if you want to, we can put it outside of parentheses now, or just keep in mind when you split up each log, they're all going to get that 1/3 as the exponent. So 1/3 log base 6 of x squared plus log base 6 of y to the 6th power plus, or this is minus because we're dividing now, log base 6 of z cubed. So now I can move my exponents in front of the log that they're attached to. I'm also going to distribute this 1/3 to all of my logs. So here I have log base 6 of x times 2/3 plus, this would be 6/3 log base 6 of y minus 3/3 log base 6 of z. So we could simplify a little bit more. 6/3 would turn into 2, and 3/3 would just turn into 1. So this would be our answer. Now let's do the opposite, and let's condense and simplify. Let's do C. So any coefficient is going to turn into an exponent. And then if we're subtracting, we're going to divide those. So anything that has a minus is going to go in the denominator. Anything that's positive is going to stay up top. So I have log base 2 of 3 cubed on top over x to the 4th power times y to the 3rd power. And then we can simplify this a little bit more. What's 3 cubed? 27. Perfect. So simplify it all the way. Let's do E. So when we are subtracting, we're going to divide. So we have log base 4 of 48 over 3. What's 48 over 3? Awesome, 16. So log base 4 of 16. Can we simplify this anymore? Awesome, we can change 16 to be 4 squared. So I have log base 4 of 4 squared, which would simplify to what? Just 2. Perfect. So last page, we're solving. So we've got exponential equations, we've got log equations, we are solving. So we always, if our x is in the exponent, you're most likely going to use logs to help simplify. If your x is in a log, you're most likely going to use exponents to simplify. Unless you can get the bases to be the same and you can get them to cancel out that way. For A, what would we do here? Awesome. We want to get the base with the exponent all by itself, so we have to divide by 4 first. So we have e to the power of x is equal to 4. Now how can I get the x out of the exponent? I can take the ln of both sides. Perfect. So ln of e is going to cancel. We have x is equal to the ln of 4. This would be how we would leave our answer. Since we don't have a calculator, just leave it like this. All right, let's do B. What should we do first here? You could, if you would rather see this as log of e, you could do that. Then what would we do? Yeah, we can put this into exponential form. Since we're taking the log of x, we want to get the x out of the log, so we'll put it into exponential form. So e to the 5th power is equal to x squared. Then what would we do? So our x is already all by itself. If we ln both sides, it would just kind of reverse what we did. How would I solve for x in a normal equation like this? Square root both sides. So we could square root both sides, which would be the same thing as saying e to the 5/2 power. Just to make it a little bit neater instead of taking the square root of an exponent. Either way would be fine. I would take either one as an answer, but this would be our answer. Another way that we could have solved this, if you didn't want to change it to log base e in the beginning, we know that e cancels out with our ln, so we could make the big base e on both sides. So e to the power of ln is going to cancel. We're just left with x squared is equal to e to the 5th power. Or if you wanted to, another way of solving this, you could move the 2 in front of the ln first and then divide it. I'll do that up here. So if we have ln of x squared, but we're going to move the 2 in front, is equal to 5. I can divide both sides by 2. So ln of x is equal to 5/2. And then make the big base e on both sides. So we get x is equal to e to the 5/2 power, which is the same. So different ways to solve these. What about for c? What can we do for c? Awesome. We can see here that we can get the bases to be the same. So let's change 81 to be 3 to, you said the 4th power? Yeah. 3 to the 4th power. What do I do with the exponent that's already there? Multiply them. So we get 3 to the power of x plus 1 is equal to 3 to the 8th power now. So if you have an exponent that's already there, just multiply it to your new exponent. The 3's are going to cancel. So x plus 1 is equal to 8. Subtract 1. X is equal to 7. Any questions there? For D, if we have a log equals to a log, they'll cancel. We can just set what we're taking the log of equal to each other. So x minus 3 equals 6. So x is equal to 9. Anytime you have a log equation, check your answer. We can't take the log of a negative, so you could just lightly plug back in the 9 into your x here. 9 minus 3 is 6. It's positive. We're good. So 9 works as an answer. So anytime you have a log or ln, you want to check your answer. What about for e? What would we do to solve e? Awesome. You can rewrite this into exponential form, or you can make the big base 5 on both sides. It'll cancel here. So x plus 2 is equal to 5 to the 2nd power. So x plus 2 equals 25. Subtract 2 on both sides. X is equal to 23. Just lightly plug it back in. 23 plus 2 would be 25, so we're good there. Any questions there? Let's do F. So we can only cancel out our logs if we have a log equals a log, but here we don't. We've got 2 logs on one side. What could we do? We can condense it. Awesome. Anytime you have 2 logs on one side, if you can't move it over, we could just add the log to the other side and get a log equals a log. That would be the first thing you'd want to check for, but we can't just do that here because we have a 4, so we can't get a log equals a log. So let's condense it. Condensing would be the second thing that we would want after we know that we can't just move it over. So here when we condense, since we're subtracting, we're going to divide. So log base 2 of x over 5 is equal to 4. What would we do next? we can change it to exponential, so we can make the big base 2 on both sides. So x over 5 is equal to 2 to the 4th power. So x over 5 is equal to, what's 2 to the 4th power? 16. And then what's our last step? Multiply both sides by 5. So x is equal to 80. Perfect. G is super similar. You want to condense your log, or the ln on the left side, but you'd solve it the same way. Let's look at h. So h we did from the notes. This one's a little bit funky because we can't get our e's to combine because they have different exponents. They're not really like terms. But this looks super similar to x squared plus x minus 30. What would we do to solve something like this? If we had x squared plus x minus 30, how would we solve? We would factor. So we're going to do the same thing here, but instead of x's, we have e to the power of x. So when I factor, I would say e to the power of x and e to the power of x. What are two factors of negative 30 that add to 1? Negative 5 and 6. Perfect. So e to the power of x minus 5 and e to the power of x plus 6 equals 0. So now we have two little equations here. We're going to set them both equal to 0. So e to the power of x minus 5 equals 0. E to the power of x plus 6 equals 0. I can add 5 on both sides. So we get e to the power of x equals 5. What would we do next to get x all by itself? Take the ln of both sides. So ln of e cancels. We're left with x is equal to ln of 5. This would be how we leave our answer. Let's do the same thing with the second one. I'm going to subtract 6 on both sides. E to the power of x is equal to negative 6. What would we do next? Take the ln of both sides. Can I take the ln of negative 6? No. This does not work. You can't take the ln of a negative number. You can't take the ln of 0 either. So this would give us no answer, or our answer would only be the ln of 5. So it's not that it's no solution because we still had another solution, but the ln of negative 6 does not work out. Does not give us a second answer. We only have one here.